Hey there folks. So in this video we're going to look at how we can remove overlapping points that we have created when they exist kind of within one individual path of our PCG. So what we've looked at before for removing overlapping is difference. And I'm just going to jump over to this combination example I've got over here, which has quite a few things in here. It's got some ground cover, it's got some trees and rocks. And you'll notice that this difference node, we can use it. We can take these points in and we can say, I want to get rid of the difference where I've got points that come from somewhere else. So in this case here, it's these rock points. They're coming from a completely different surface sampler. And as I kind of refer to them, they're coming from different paths of our PCG. So this is the rocks path. This is the ground covers path. So I can take points from somewhere else and I can remove the difference from them. But what about if I've got lots of points within this area in just this individual path and they're overlapping? So I've created this demo here just to show you what this is, and we're going to use a node called self-pruning to be able to get rid of those. So I'm going to actually sample the landscape and I'm going to use the surface sampler, and here I'm creating point extents that are 200, 200, 200. And I've also reduced the looseness down to really, really low numbers just so I can show you what's going to happen when all of these end up really close to each other. And if I then go to transform points, because at the moment, even though they're close to each other, they're not actually overlapping. You can see even down there at the bottom, they're very close, but not quite overlapping. But the moment you come into this transform points and you start rotating them anywhere between 0 to 360 degrees, and you rescale each one of them to be either 0.7, so 70% of its size, up to 1.4, so 140% of its size, what we're going to end up with is this. And this gives me this absolute mess of points that are all overlapping. Now that seems like a problem, but it's not actually that bad, because we can use this self-pruning node to start looking at each of these points and actually removing any of the overlaps that exist. So I'm going to plug this in and I'm just going to debug it here and watch what happens if I turn on and off this transform points here. So you can see we go from having loads of overlaps to no overlaps. All of these are individual now. And you can see as I turn it on and off what we've got rid of. Now I'm going to focus on these two dark grey kind of big cubes that are here, and you can see that there's loads of cubes around them and they're much, much smaller. So what it's doing is it's removing those smaller ones around from there. Well, why is it doing that? Well, that's because the self-pruning node, its default pruning type is large to small, and that basically means it's going to favour the larger objects and remove the smaller objects from them. Now, if we can click on here, we can actually go to small to large, and you'll see it's the opposite. It's going to go and favour the small objects, and we end up with lots more smaller objects, and it's removed any of the larger objects that were overlapping them. We also have this radius similarity factor, and you can see the default value of that is 0.25. And what that basically means, it's a value that allows us to judge how close two different objects are to each other in terms of their equal sizes. So if a box extent was around at 10, this 0.25 would allow us to say that a box of 0.75 and a box of 12.5 are equivalent to each other. And that just means that if I start moving these values around, I can start seeing a difference between what it considers as similar boxes, what it considers as two boxes with the exact same size. So just play around with that value, and it's just going to kind of give you a different seed in terms of the outcomes of this. But there we go. Here I'm just taking all of these and I'm using those to remove any of the overlaps, and it's a really useful one just to go along, and as we start transforming points and seeing any of those overlaps, we can use this self-pruning to get rid of them. You might see this used quite a lot if we ever go into something like our bounds extents or bounds modifier. So bounds modifier and extents modifier. What you might find is that your original points that you were working with, you might end up resizing and rescaling those. At any time that you resize and rescale, you might end up with these overlaps if you make it bigger. So where you have that, you can use this self-pruning node to just get rid of those overlaps and just tidy up this. Obviously, if you wanted other things to be removed from here, so let's say that I was going to use these to spawn rocks and I also had trees, well, that's where we'd maybe look at the difference modifier and the difference node to obviously get rid of the rocks where the trees are or the trees where the rocks are. But this should give you a lot of ability now to just get rid of those overlaps. Thanks for watching, folks. If you enjoyed this video, then please consider subscribing to access more of my Unreal Engine content.